Gee, Toto, I don't really understand why these kids don't understand electron configuration. It's not that hard, it's just like finding an address. Well, I'm gonna go to sleep and hopefully I will find a better way of explaining it tomorrow. Good night.
Here you are.
I don't think we're in Oak Lawn anymore, Toto. Oh, look! Here comes the Cowardly Lion and the Tin Man!
Hi, Dorothy.
Why, hello! I'm hoping that you guys can help me learn about electron configuration here in...
Oh, I don't know. I've never heard of that before.
Of course, Dorothy.
Thanks, Tin Man!
Oh, electrons! Oh, those are scary. Those are scary.
Well, the important part of electrons is that they're all responsible for the bonding activity of atoms.
Oh, atoms! Atoms! Oh, I don't like atoms.
The Cowardly Lion is very scared.
He's very scared. It's kind of a little exhausting after a while. Alright.
So where do we find the electrons?
Well, that's the thing. The electron configuration is like the address of the electrons.
So like the yellow brick road on how to get to Oz.
Exactly.
What's a nucleus?
Well, Cowardly Lion, it's the part of the atom where the protons and the neutrons live.
Oh, okay, I got it.
All right, so electrons are found in energy levels or distances from the nucleus with the protons, neutrons, and electrons.
Oh, that sounds like it's far.
It is very far. Like like Oz.
Oh,
Oz is
okay,
very far.
very good. So like we found the Cowardly Lion in the forest.
Exactly.
Okay,
Exactly.
got it. All right.
You know. So the further it is from the nucleus, the further the electron is, the more energy it takes. So the higher the energy level.
I don't like to go far from the nucleus. I like the nucleus.
The nucleus is very comforting.
Yes.
It's like Glinda the Good Witch.
It is, Glinda.
So here's our periodic table. There's a couple of important things to note. Here, let me switch places with you.
Okay. Oops,
There we go.
excuse me, Tin
It's a bit
Man.
easier.
Making me nervous.
No sudden
More Cowardly
movements. I
Lion,
know.
yes.
He's
Don't worry,
so
Toto
sad.
will not bite.
Woo, woo.
So in our periodic table, we have rows, and
Okay.
those rows correlate to the energy levels.
So like if Cowardly Lion, if you're in like row 5, you would probably have 5 energy levels?
Ooh, does that mean I sleep a lot or am I awake a lot?
I don't know that ties to the electron.
Oh, okay, sorry.
But there are no stupid questions. Howard.
Right, exactly. You're learning today.
All right. The groups are the columns, and those correlate to how many valence electrons there are.
Okay, so like if I'm in group 1, I would have like 1 valence electron.
Exactly. Group 2, 2.
Okay.
The only trick is 13 has 3, 14 has 4.
So just subtract 2.
Yeah.
Okay, that's pretty easy.
Not
Well,
too
that makes sense.
Yeah.
Exactly.
Right?
Science does make sense.
It's true.
Right.
Toto's getting a little
He's
wobbly here.
Yeah.
Can we go back to the nucleus at some point?
We'll get there.
Okay.
Don't worry. So there are blocks on the periodic table, and the blocks on the periodic table correlate to their electron configuration. So we're going to throw out some letters here, but don't worry, it'll make sense in a second.
Okay.
So on the left-hand side, that's called the S block because the electron configuration always ends with S something.
Okay. And since there's only 2 groups, I'm assuming it only holds 2 spots for electrons?
Yeah, exactly. So
Okay.
S1 or S2.
That makes sense.
Over on the other side is the P block.
All right.
6 spots can hold 6 electrons.
Oh.
Oh, that makes sense.
Yeah, see? We got the D block right stuck in the middle.
Okay.
And then down below is our F block.
Okay.
For actinides, lanthanides, and actinides.
Gotcha.
Now-
So like in the S there's 2, P there's 6, D if I count those that's 10.
Yep.
And then F there's 14.
Exactly.
Oh.
That's very easy.
Right?
Okay.
Yes,
I got
nice
that.
and easy. Here's the problem, though, Lion. There's one exception.
There's always
Helium.
an exception.
There is.
You know, I don't like helium. Helium makes me nervous.
As it should.
Yes. It probably makes your voice as high
Makes my
as
voice
it
really high, too. I don't like it. Can we go back to the nucleus?
We'll get there. We'll get there.
So our one exception, helium, that's part of the S block. But
Okay.
that's it, and it
Because
just...
technically it's like over where that little hole is on the left side.
Yeah, it kind of doesn't fit real nicely. It's
Okay.
a mess. It causes
All
so
right.
many problems. Okay. So, we're going to talk about orbitals. Orbitals are those letters.
Okay.
Orbitals are just the shape that the electron cloud forms.
Oh.
So, there's those letters correlate to different shapes. Now, you're
Oh.
not going to really have to know the shapes. The shapes aren't super important.
Mm-hmm.
Just know that the orbital refers to the shape the electrons are orbiting in.
Do those flying monkeys live in the electron cloud?
Kind of like that, yeah.
I don't like them either.
No, they're scary. But when they fly, they make a certain formation,
Oh.
kind of like the electrons.
Okay.
Very good.
Yeah. All right. So, like we said before, the electron configuration is almost like the address of the electron, or where the electron is around the nucleus.
So, like, would each element have its own address? Like, each house on the block has its own address?
Exactly, because they all have a unique number of electrons.
Okay.
So carbon's configuration is 1s2, 2s2, 2p2. That's kind of a lot, and it's a little confusing.
Right.
But let's break it down.
Okay.
So let's say, for example, 1s1.
Okay.
Right? That big 1 refers to my row number.
Energy.
Yep.
Or how much energy. Yeah,
Got it.
exactly.
Got that.
Exactly.
Okay.
Boom. That little 1 is my group number.
Okay.
So it's kind of like battleship, right? So if you know your row and your group, you know where the
you
atom.
meet? Oh,
Exactly.
okay.
I like being the aircraft carrier when I play.
Yeah. You play that in Oz regularly?
I try to.
Okay.
By himself. And last but not least, that letter is the shape that we were talking about. So it's where it is on the periodic table and the shape the electron is around it.
That's not hard.
No, not too bad. So let's take, oh, there you go. So what element would have a configuration of 1s1?
Well, luckily for me, I carry this handy-dandy periodic table in my basket with
Everybody should have one of
Yeah.
those.
Exactly. And if I look here on the periodic table, row number 1 right here, okay? And then you said S, so I know it's going to be on the left side.
Mhm.
It's only got 2 columns. And since it only has 1 valence electron, I know it's in group 1, it's got to be hydrogen.
There it is.
See?
I like hydrogen better than helium.
Yes. And
Helium scares me.
All right, so now here's how this works out. This is the filling order for every single element on the periodic table.
Okay.
So down below, that's the filling order of every single element. And it gets a little complicated and tricky, but once you get the hang of it, it's not too bad.
Okay.
Now here's the thing to remember. You don't go like 1s2, you just don't go in order, then 2s2, then 3s2, then 4s.
Okay.
It has its own order. It's kind of on the diagonal.
Oh, so I would start with like 1s2,
Mhm.
and then 2s2, and then 2p6,
Yeah,
and then I'd go to 3s2,
exactly.
and then, oh.
So you're taking the diagonal. So you start here at 1s2,
Okay.
and then you start up at your... It's like a slide. So I slide down to
Oh,
1s2, then I go
okay.
up, then 2s2, then I go
So-
up, and I'm sliding on 2p6, 3s2.
Got it. So these are just basically telling you, like, the directions. Like, so say I lived on the 4s2 block.
Mm-hmm.
I would start leaving, obviously Oz, because we're no longer at Richards.
No.
1s2, and then that would be like saying, you need to turn left here.
Exactly. It's like saying the Emerald City is 7p6, and this is our Yellow Brick Road.
Oh.
We always have to follow our electron
Ooh,
configuration.
That makes sense to me.
Mm-hmm.
See? And if the Cowardly Lion can get it.
If I can get it, anybody can get it.
Exactly.
So it follows this nice little order.
That's a beautiful animation you have, Tin Man.
It was, thank you.
Mhm.
All right, let's practice a couple.
All right, so let me bust
Practice
out.
makes me nervous.
All right, Cowardly Lion, you're on. Are you ready?
All right, lithium. So, first off, you got to find lithium on the periodic table.
That's Li. That's way over to the left.
It
Very
is.
good.
It is. All right, so period number is the row. What row is it in?
To row 1.
Nope, go down one more.
Oh, sorry, 2.
It's
There
in
you
row
go.
2. Very good. So, if it's in row 2, how many energy levels should it have?
2.
2. Good, because the row is the
Oh,
energy
wait a
level.
minute. 2. I'm going to be confident.
That's right.
That's
That's
right.
right.
Working on that
All right.
confidence as a Cowardly Lion.
Now, group numbers column. So, what group is it in?
1.
Perfect. So, if it's in column 1, how many valence electrons should it have?
1.
All right, perfect. All right, so now what block or what shape is that orbital? What letter is that?
P, isn't it?
Close.
Oh, wait a minute. S?
S, very good. It's very S. All right, and then so what would the electron configuration be for lithium?
So we have to get to lithium. So we would start with row 1. So we'd
Yep.
write 1, and then we'd S, and then since we passed 2 houses, I would say 2.
Yep.
And then I would go to 2, which Cowardly Lion told me to stop there, and it's S1.
Perfect. If we take a look, probably should have done this with you guys. Exactly. It's 1s2, 2s1.
Perfect.
Oh, I
Alright.
get it now.
Yeah. All right, let's try one more. Let's try boron.
You know, I'm kind of nervous.
I know, it's okay.
Okay.
Dorothy's not very mean. She's very nice.
Okay.
Toto. All right, so find boron on the periodic table.
B. That's way over to the right.
Good.
Yes.
It's number 5. Perfect. Excellent.
Awesome.
All right, so what period, what row is it in?
It's in row 2.
Fantastic.
Awesome.
So how many energy levels would it have?
2.
Oh, whoa.
Man, he's getting real confident back
On
here.
fire. Okay, group number. What column is it in?
13.
Oh, very good. That should be 13.
Yes.
We'll fix that.
You better fix that. That's
Yeah,
not good.
that's-
Kids get confused.
I know.
on that.
That's
okay.
just,
got it.
that's awkward now.
13.
13. All right, so how many valence electrons should it have?
3.
Fantastic. All right, what letter orbital is it in?
That's way over to the right. Was that P?
Ooh, very good, Lion. Very
I've got a
good.
good memory.
Yeah, you
Yes,
do.
you're doing
Yes.
very
I like
yes.
the nucleus too. Did you know that?
Yes,
Yes.
the nucleus is your favorite.
Not at all like the
place.
Scarecrow. That guy. Man, we tried making a video with him.
He was.
Yeah, we had to. All right, and then so the configuration, we would start with the ones.
Okay, so I'd say 1s2, which would get me as far as helium.
Yep.
Then I would go to row 2, and I would say 2s2 because I would pass lithium and
Right.
beryllium.
Mm-hmm.
Yep.
And then I would say 2p since we're now in the p block.
Got it.
And I would say 1 since it's the first element in the
Got
p
it.
block.
Oh, okay.
Fantastic job.
Yeah.
That's
Alright.
it. All right.
Ooh, do I get a name?
Yeah.
Sure.
Oh,
Yeah.
That would be
Very
fine.
cool.
If they
Very
gave
cool.
grades in Oz, you would get a name.
Oh, standard.
We're standard-based grading in Oz.
Yes.
All right. So I hope that kind of cleared it up. Hopefully you can follow the electron configuration and find your way back to Richards High School.
Yes, I'm just going to click my heels 3 times so I can get out of here.
All right.
I wish I was at Richards. I wish I was at Richards. I wish I was at Richards.
Goodbye.
Bye.